Hello everyone, welcome to our YouTube channel Electronics Maddie. Today we are going to talk about design and simulation of flyback converter in Matlab. This is a circuit diagram of a flyback converter. A flyback converter is basically a DC to DC buck boost configuration converter that provides electrical isolation. As we can observe, there's a transformer that is used. That is one of the major differences between a non-isolated converter and an isolated converter, and these are generally used for protection purposes compared to that of a non-isolated converter. So let's get into the design part of it. There are certain parameters that we need to assume before getting into the design. So these are the values that we are assuming. Step one is to determine the duty ratio. In order to determine the duty ratio, we have this formula. So let us assume a turns ratio of 3 and then find out the duty ratio. So we will be getting approximately 0.3571, that is 35.71 in this case. And one of the most important thing to note is these are the general steps with respect to hardware design point of view. However, in MATLAB, we already have something called as linear transformer, which can directly take the input and output voltages, so we don't have to find the turns ratio and all those things and enter them in MATLAB. Next step is to determine the capacitance value. The capacitance is being given by this formula by substituting all the values of R, C, and F. We'll be finding out the value of C from this formula. So we'll be getting 17.85 microfarad. So once this is done, these are the components that are essentially required to simulate in MATLAB. So one of the components that is missing out here is linear transformer. I'll be showing it out in the simulation part. All right, let's get started in MATLAB. So I've actually placed the components that are required. So just to save a little bit of time, so the amount of capacitance that we are choosing is 17.45 microfarad. So let's enter the value of the capacitance. The resistance that we have chosen is 40. We can calculate it from the Ohm's law. The formula is already given, so we'll be able to do that. And once that is done, one of the most important things to remember is we don't need these measurement ports. So it's very important to disable them since we are not using it. And one more thing to be noted is that how to find out a linear transformer. We can directly go in and search here and we'll be able to find out a linear transformer. So add this block in model and title, and then you will be able to get started with the linear transformer part. So in linear transformer, we have to convert. So we are using this in SI unit. So it's the actual unit that we are using it. So we need to ensure that it's there in SI units, and the value is 40 watts that we have chosen according to our design, and 100 into 10 power 3 is the value that we have chosen here. So rest of them with respect to this will make it 0 because we are not requiring the value of resistance drop and the inductance. So let's ensure that these values are set to 0, and once that is done, we'll have to set the value of the primary voltage, which is 24 volt, and the secondary voltage that we require is around 40 volts. So this transformer does not require any kind of turns ratio information. It's not a three winding transformer. Just disable that, and then we can click on OK. Once this is done, we can set the input value of about 24 volt that is being designed to, and connect these components according to the circuit diagram. So we'll be doing that, and we're using a pulse generator in order to trigger the MOSFET. So we have selected that as well. A diode is placed in the forward direction. We are choosing a resistive load, so we are connecting it across a resistive load as shown in the circuit diagram, and we're using a voltmeter to determine the voltage across the load. So we'll be connecting it across the resistor R, and a scope is used. This is a scope. A scope is used to determine the like the waveforms, to see how the waveforms appear like. This is the RMS value block that gives you the RMS value, a display block to display the values that is there. So let us set the pulse generator parameter values. So the time period here is 1 by 100 kilohertz. So we'll be getting 1 into 10 power minus 5. So this is one of the most important steps. And the duty ratio that is set in our design is 35.71. So we'll set that as well. So once that is done, reduce the simulation time to zero point 0.1 seconds. We don't need such a huge amount of time for any kind of simulations when it's not any like when we have a resistive load, especially. That's only applicable for dynamic loads where the load is very high. All right, you can see the display over here, which is showing 38.26, approximately close to 40. We'll not be getting the exact value due to the internal drops of all these values in place. Matlab automatically takes those values. Let us see the output waveform by double clicking on the scope. All right, here we are. So we can see the output voltage approximately close to 40 volt. So that is one of the objectives of our design, and we are approximately getting it. This is the amount of ripple that is present. We can further reduce it by choosing suitable value of capacitor. One thing that is not included in this design is we've considered 0.5% ripple while calculating capacitance value. That is to be noted as well. If you like this video, please do like it and subscribe to our channel for regular updates. Thank you.